Good morning, good afternoon, good evening. Hope you're all well. So today we are going to discuss the 20th problem in the TLE Eliminator CP sheet, 800 rated problems. The problem name is Twin Permutations. So let's start. Let's first start by reading the problem. You are given a permutation A of length n. Find any permutation B of length n such that the sum of the first elements is less than equal to the sum of the second elements, which is also less than equal to the sum of third elements, and so on. It can be proven that a permutation B that satisfies the condition above always exists. Below is the definition for a permutation. We will be given n, that is the size of the permutation, and the elements in the permutation A. All the elements of A are distinct. We need to output any permutation B that satisfies the constraints. So let's see the first test case and understand the question. We are given 1, 2, 4, 5 and 3. We need to make another permutation B. This is A, this is B, so that all the sums, the sum of this is less than equal to the sum of this, is less than equal to the sum of this, which is less than equal to the sum of this, and that is less than equal to the sum of this. So one thing we can note is we can have all the sums as equal. So let's try to make them equal. So 1, 2, 4, 5 and 3. What is the highest sum that we can have? So 5 plus 5, that is 10, and what is the minimum sum is 2. So we can take any sum between 2 to 10 to test whether we can get the sum or not. So let's suppose I take the sum of 7. In order to get the sum 7, I need to add a 6 here, I need to add a 5 here, I need to add 3, 2 and 4 here. But this is not a permutation, so 7 is discarded. Let's see for 5. 4, 5 and 3. I'll add 4 here, I'll add 3 here, I'll add 1 here, I'll add 0 here, I'll add 2 here. Even this is not a permutation, so 5 is also discarded. Now let's move on to 6. 1, 2, 4, 5 and 3. Let's see how to make it 6. We'll add 5 here, we'll add 4 here, we'll add 2 here, we'll add 1 here, and we'll add 3 here. This is a valid permutation, and therefore we can have the answer 6. So this is the B array that we can print. This is a valid answer. So one thing we can notice from here is we can always make the array B, and the value that we can make equal to is the maximum element plus 1. We can always make the array using this value. So that's all we need to do in this test case. Let's see the last test case as well, just for a better understanding. 1, 4, 3 and 2. The max element is 4, so the element would be 4 plus 1, that is 5. In order to get 5, it will be 4 here, it will be 1 here, it will be 2 here, and it will be 3 here. This is a valid permutation. So let's write some code here. We'll be taking input n, then we'll be taking the array as input. Now the max element would be n plus 1. N is the number of elements, so 5 was the number of elements, so we had the max element as we had the element equal to n plus 1. So we can simply have n plus 1. Now we'll make another array B of n, or we can take it as an answer of n. For answer of I is equal to n plus 1 minus ARR of I, and in the end we'll just print the answer. That's all we need to do. I hope you got the approach. So let's move on to code the same. I have my boilerplate code here. We'll be given an n. We'll take n as input. We'll have an array ARR of size n. We'll take the whole array as input. After taking the input for the array, we'll define a max element that is equal to n plus 1, or we can just have the sum, required sum. We'll make another array B of size n, and we will populate the B array. Or let's just rename B to answer. Or answer of I is equal to the required sum minus AR of I, and in the end we'll just print the array. So auto I in answer cout I. The time complexity is big of 2n. One optimization we can do here is we can move this while taking the inputs itself. So since the required sum can be known just after taking the n inputs, we can shift all of this above, and we can reduce our time complexity to big of n, not big of 2n. So we'll just paste it here. This is not required now. Just after taking the input, we can have our answer. Right. So let's try for the sample test cases now. 5, 4, 2, 1, 3. So the sum is 6 and all the elements sum to 6. 1, 2 and 2, 1, the sum is 3. 1 and 1, the sum is 2. 3, 2, 1 and 1, 2, 3. 4, 1, 3, 2 and 4, 1, 2, 3. Yeah, the sum is 5 now. Yeah, so this code gives us the correct result. So let's try to submit it. Paste and submit. And it got accepted. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Also, this is a playlist for all the problems in the CP sheet. Do check out all the other problems as well. Like the video, subscribe to the channel and share it with your friends. Thank you.